Welcome back to Data Dive, the podcast where we explore the ins and outs of database management, analytics, and everything in between. I'm your host, Your Name, and today we're diving into a crucial topic for anyone working with databases, maintaining data consistency during transactions. We'll unpack the challenges of querying large databases, the power of snapshot isolation, and the intricacies of atomic update operations. So grab your headphones and let's get started. Imagine you're running analytics on a massive database or conducting integrity checks to ensure your data is reliable. The last thing you want is to end up with nonsensical results due to inconsistent data. This is a common challenge faced by many database administrators and developers. One popular solution to this issue is snapshot isolation. But what does that really mean? Snapshot isolation allows transactions to read from a consistent snapshot of the database as it existed at the start of the transaction. This means that even if other transactions are making changes while you're reading, your view of the data remains stable. This is particularly important in environments where multiple users are accessing and modifying data simultaneously. So how does snapshot isolation actually work? It largely relies on a technique called multi-version concurrency control, or Mvcc for short. Mvcc maintains multiple versions of data, preventing conflicts between concurrent reads and writes. Think of it like having different versions of a document. While one person is editing the latest version, another can still access an earlier version without any hiccups. However, navigating the world of isolation levels in SQL can be a bit tricky. You might have heard terms like repeatable read and snapshot isolation thrown around, but they don't always mean the same thing across different database implementations. This can lead to confusion, especially when you're trying to ensure that your data remains consistent across various transactions. Another issue that arises in this context is the lost update problem. This occurs when two transactions read the same data and then both try to update it, but one of the updates overwrites the other, leading to data loss. To mitigate this, using atomic update operations can be a game changer. These operations allow you to perform updates in a way that ensures no other transaction can interfere until the operation is complete. For example, if you're incrementing a counter in a relational database, atomic operations can handle that safely without requiring a read-modify-write cycle. This not only simplifies your application code, but also enhances data integrity. While atomic operations are fantastic for straightforward tasks, they might not be the best fit for more complex updates, like editing a wiki page. In those cases, you might need to rely on other techniques to maintain data consistency. One such technique is cursor stability. This approach ensures that once a transaction reads a piece of data, it can continue to work with that data without worrying about changes from other transactions. It's a way to enhance isolation during updates, making it easier to manage changes without stepping on each other's toes. Another method is single-thread execution, where operations are executed one at a time. This can be beneficial in scenarios where you want to avoid concurrency issues altogether. However, it's worth noting that while single-thread execution can simplify things, it can also lead to performance bottlenecks if not managed properly. To recap, we've explored the challenges of running queries on large databases and how inconsistent data can lead to unreliable results. We've highlighted snapshot isolation as a solution, thanks to the power of multi-version concurrency control. We also touched on the complexities of SQL isolation levels and the importance of atomic update operations to prevent issues like the lost update problem. Maintaining data consistency is paramount in database transactions, and understanding these concepts can help you navigate the complexities of database management more effectively. As we wrap up this episode, remember that the right approach to data consistency can make all the difference in your application's performance and reliability. Whether you're using snapshot isolation, atomic operations, or other techniques, The goal is to ensure that your data remains accurate and trustworthy. Thank you for tuning in to Data Dive. If you enjoyed today's episode, don't forget to subscribe and leave us a review. We'd love to hear your thoughts on this topic or any other database challenges you're facing. Until next time, keep diving deep into your data. This is your name, signing off from Data Dive. Happy querying!